Electrical components are in parallel if they are on separate branches of a circuit that run alongside each other. This would mean that if two components are in parallel, there is no path around the circuit that goes through both of them. Let's look at some circuits with two lamps and determine if they are in parallel. In this circuit on the left, we have the lamps on different branches. Since these branches run alongside each other, the lamps are connected in parallel. We can also see this because there are two possible paths around the circuit, one that passes through the middle lamp and another that passes through the bottom. So there is no path that can pass through both lamps. But what about the circuit on the right? Well, we see a lot of branching paths in the circuit, and the lamps aren't on the same branch, which might make you think they are in parallel. But since their branches don't run alongside each other, they actually aren't parallel. We can also see this because there is a path around the circuit that will pass through both lamps. So if you're asked to draw a circuit with components in parallel in your exam, make sure not to make this mistake. Most circuit diagrams given to you, though, won't be this complicated. Now, why is it important that we make this distinction? Well, when components are connected in parallel, a current will be split between parallel branches. Let's see what this means by taking a look at another circuit with parallel branches and components. Remember that when a current flows around a circuit, it's because charge carriers, in this case delocalized electrons, are travelling around it. When these charge carriers reach the junction, they'll split up and travel down different branches. Some will travel along the middle branch, and some will travel along the bottom branch. This means that these two parallel lamps will have different charge carriers flowing through them. In other words, the current has been split between these paths. Now, you won't need to explain this for your exams, but it's useful to understand what's happening in the circuit when we learn about the currents and potential differences for these components. But what other property will parallel circuits have? If a component breaks, then a current can still flow through components connected in parallel with it. So let's suppose we have this circuit with two parallel lamps, and then one of the lamps breaks. This means the current can no longer flow along this middle branch, as it can't pass through the lamp and complete a loop around the circuit. However, the bottom lamp is still working, so the current can still flow down this branch. So overall, the current only flows through the bottom lamp, as this is now the only path around the circuit. This is why most real-life circuits, such as the mains in a house, are set up with parallel branches. If one component in the circuit breaks, then the rest of the circuit can still work around this.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!